we're going to be learning how to do our water quality testing, and we're going to be using our Q values to determine the health of the water in the Middle Fork River. You'll find that here we have collected data, and we've done this in class. This is what the blank sheet looks like that I had you solving and filling out. I'm going to walk you through it. I will walk you through it test by test. So this one will be a little bit longer, but not significantly or not substantially. I want to make sure that this is the information that we're working from. We will be adding the test equipment as we go. So here goes. So I've filled out the test equipment. For turbidity, we'll use turbidity tubes. Temperature change, we'll be measuring with the digital thermometers. pH paper for pH. Phosphate, nitrate, and dissolved oxygen, we'll be adding the Hawk spectrophotometer. So here goes. I want to make sure you understand where the values come from. That we're only testing, there's only 6 parameters here. 1, 2, 3, 4, 5, and 6. But there's 9 total that go into professional organizations. We don't test biological oxygen demand, total solids, or fecal coliform. And if I add up the weighing factors of these 3 parameters that we do not test for, if I add these together, I get this value of 0.34. So you'll find that at the end of our tests, we are not going to be testing out of 100% of them. We're going to be testing out of, well, 100% minus 34%. We have to recognize that we are not testing 34% of the total weighing factor that goes into calculations. Right? If I add up these weighing factor columns, we're missing 34% of the total tests. So we must recalculate this using this new, we'll have to subtract this at the end. And we'll come back to this. I'll make sure we drive that home. So here goes for turbidity. If I use, so I get these values, 65 centimeters in a turbidity tube. I have to use my NTU value conversion chart first. So 65 you'll find falls in this column. That's a 7. If I follow my 7 all the way up, I find that my Q value is, I'm going to say it's about an 82. So here, I've got this value of 82. So my Q value, in this case, is an 82. If I take 82 times 0.08 for my final value, I get a 6.56 for a value. And that's important here. Take a look here. Temperature. Temperature, I have provided information 15 degrees C and 15.5 degrees C. Therefore, the difference is 0.5. 0.5 is just barely over here. I'm going to follow it all the way up, and I get it's about a, I don't know, right at, I don't know, let's say I'm going to go with 92. So 92, that's pretty good. And 92 times 0.1 gives me 9.2. So far, so good. Now I'm going to go with pH. pH is an easy one here. pH had an average of 7.5. I follow this up. Doop, 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 doop. And I get yet another 92. And 92 times 0.11, do that on my calculator real quick, I get 10.12. Moving on. Phosphate. Phosphate, if it has a value of 0.1 parts per million, my Q value, 0.1, just barely past the dark line here, I can go with a phosphate value of about, I don't know, 95. That's a really high score. So I've got a 95 here. I take 95 times 0.1, and I get a value of 9.5. Moving on, nitrate. Nitrate has a test value of 0.6 parts per million. Once again, that's really, really close here, 0.6. I'm going to call this value here, all the way up here, 94, 95. It's pretty high on the rank in the scale here. So I'm going to go with we'll go with 95 for that one as well. 95 times 0.1 is 9.5. And that's our 5th test. We're going to do one more here with dissolved oxygen. So dissolved oxygen, and this one takes a couple steps. You'll need to make sure that we go back and remember, I can average my temperature at the beginning. It was 15.0 and 15.5. I get an average of 15.25 or 15.3. So I'm going to plot this point up here on my temperature. So 15, I put a point here. I find the value of the concentration here was 5 parts per million. So I put 5 parts per million down here. I connect the lines, and I go from 15. I draw a straight line. Not a very good job here. And I got a value of, a Q value of 50. And 50 times 0.17, right? 50. Notice my 50 here. Where's it at? let's see, 50 is my saturation percentage. Excuse me, hold on, pause that for a minute. And this value here, my 50 is my saturation percentage. I come over here, I find 50 on here, and I find this to be about, I don't know, 42-ish, 43. We'll be close with that. I'll go with 42 for now. Now that's a low value. Remember, dissolved oxygen is 17% of the total weight. This is a very high weighing factor. So I take 42 times 0.17, and I get a value of 7.14. And now I've got all my data. So let's look at it all together. So here, just to make sure that we reiterate this, I get a 50 as I align 15 degrees in 5 parts per million, and it crosses over at 50 is the percent saturation. I follow my 50% saturation. I find it along this line here, and I see that I'm just into the 40. So I'm going to call that a 42 Q value. 42 times 0.17 weighing factor gives me a value of 7.14. So now I can look at all of my data that is completely put together. I want to make sure that we have a chance to see what this all looks like. This is what my whole data column looks like, and I want to go to my totals column. I add all this whole value, this column right here. These are the values that I'm adding together, and I get this value of 52. And here's where it comes into. The value of 52 means something. Remember, we don't test all 9 parameters, just to go back to what we said before. So we must recalculate the value of what 52 means out of 66% of all the tests. Remember, earlier we accounted for the 34% that we don't test. The total dissolved solids, the biological oxygen demand, and the fecal coliform. And as a result of that, we divide our value of 52, oops, wrong number there. We then recalculate this. 52 divided by 0.66, and we get a value of 79. And 79 I then cross-reference down here, and 79 is in the good column. Now, if you have a chance, make sure you go over this, go over it a little bit slower. I try to walk you through each one, how to use the Q value charts. Good luck.